Welcome. Thank you for joining us this morning or this evening, depending on where you're located, for CMG's General Release 2020 webinar. My name is Jeremy Walter. I am an account manager here in the Canadian region. I've been with CMG for coming up on 12 years. And I actually used to present quite a few of these general release presentations in the past and what's new presentations. Today, though, I will not be presenting to you, but I will be the fortunate one to moderate and help answer some of the questions. With me is Gerame Galban, and Jeremy has been with CMG for going on 7 years, and he is a senior reservoir engineer working in our consulting support and training group here in Calgary. Now, this webinar is going to be about 30 minutes long, and after that, we're going to have a QA session. Feel free to put your questions at any time in the questions box for the webinar, which you can find there in the side panel. To start off, just a quick review of what it is we do and who we are. We have been a leading developer and distributor of dynamic reservoir and production technologies in terms of our software development and licensing for over 40 years. We have specialized consulting services and support in order to help our clients around the world. We have customized training, including online training options, which have been rolled out this year in response to the highly changing situations that we've all faced. And of course, collaborative research efforts, which we partake in with various universities and research groups around the world. Our specialization has been and continues to be the market leader in EOR and advanced recovery processes, and of course, some of the non-advanced processes as well. These include unconventionals, such as tight and shale oil and gas, as well as EOR in those. Compositional, such as CO2, VAPEX, complex gas injection, thermal. Here in the Canadian region, we see quite a bit of this. I'm sure in some of your regions you do as well. Steam injection, air injection, hybrid processes, chemical in terms of ASP, polymers, gels, anything you can really think of. Geochemistry has been a big push over the last couple of years. And of course, our integrated reservoir and production systems modeling, the ability for us to model the full and complete networks coupled to the actual dynamic reservoir models. Our product suite has continued to grow over the years. We currently have our 3 primary simulators, the IMEX, GEM, and STARS. Our CMOST AI tool, which is utilized for history matching, optimization, and uncertainty analysis. Our builder and results pre and post processors, WinProp for modeling fluid behavior, and our newer products, CoFlow and CoFlowX, which is used for modeling of the surface network side, as well as coupling of that with the dynamic reservoirs. For any sort of additional resources, please feel free to reach out to the sales team, sales@cmgl.ca, or our support team, support@cmgl.ca. Also on our website, you will find a variety of useful information, such as what's new documentation, how-to videos, training courses that we've uploaded over the past months. We also recommend that you follow us on YouTube, LinkedIn, and of course, Twitter. With that, I will turn it over to my colleague, Jeremy, who will walk you through all of the great new features that our developers have worked so hard to put into the software for you this year. Thank you all.
Thank you, Jeremy. Again, my name is Gerame Galban. I'm a senior reservoir simulation engineer here at CMG. As Jeremy had mentioned earlier, it's about a 30-minute presentation. And that's including the, give or take, including the QA session at the end. Today, we're going to be going through some of the major features that were implemented in the new general release. This isn't going to cover all of the features that we have implemented in the new release. In order to see the full documentation on what these new features are, you can check the what's new documents available when you download the software. The way that I'm going to break down all of the new features is first I'm going to talk about analysis and visualization specific with results and some of the new features that were implemented there. Then we'll talk about some of the solutions specific to unconventional reservoirs, chemical and thermal EOR processes. We'll also talk about additional features that are shared between the simulators, IMEX, Gem, and STARS, things such as DFN, which is a new discrete fracture network modeling, as well as some geomechanics. Then we can talk about some of the performance enhancements that we've implemented in the new GR 2020 as well, resulting in much greater simulation speed up. First, I'll talk about the visualization analysis specific with results. The first feature I'll mention is going to be histograms. I already have a dashboard loaded here in Results 2020. To add a histogram, you'll click on the histogram icon in the dashboard tab, and that histogram will show up side by side with your reservoir. The histogram will show a distribution of the values of whatever reservoir property you're viewing, and you can also sync this information dynamically with time, as you can see here. We also have added the viewing of flow vectors into the new results. Flow vectors just require an output keyword in the respective simulator, and to view these flow vectors, you will see a new flow vector icon in the bottom right of your 3D view in results. I'll go ahead and set a transparency to my reservoir so that we can see these vectors in 3D, and then I'll click on the flow vector option to activate it. I can view my vectors specific to a type of fluid such as oil, water, or gas. And I can also view these vectors dynamically with time as well by clicking on the play button. As you can see here, I am viewing the way that my gas is going to move throughout that reservoir with respect to time. Well bubble plots have also been added as a new feature in the GR 2020. To add a new bubble plot, you would go into your 3D view of your model, then up at the top, go into your wells tab and choose the option to switch on your well bubbles. By default, the well bubble plots will plot your breakdown of oil, water, and gas, but here on the left side, you can also add and modify exactly what sort of production information you would like to see from the list shown. I'll go ahead and click close here and click play. And as you can see, the well bubbles appear at the wellheads, and I can easily view my production for my oil, water, and gas for my respective wells, all in the same view. Results Report is a text-based results output software that was previously only compatible with our older SR2 file systems, which are the IRF and MRF files that some of our more experienced users have probably remember. In order to use Results Report in previous versions, it would require an additional simulator output. For the latest release, we have made this software compatible with our newest SR3 file system to give our users more flexibility on how they want to output their results. To use this software, a text-based template is used to define exactly what information needs to be output. It is submitted to Results Report, and then the results are outputted into a text or Excel-based file. Results Report is very useful for obtaining specific information for layers, groups, wells, sectors, and special histories. You can also output custom tables for comparing multiple runs, tables importing directly into economic analysis packages, and also extracting specific grid information and arrays. General preferences for how users want to customize their plots have these customizations applied to every new project that they open is now available. To change these settings under the input section, click on General Preferences option. From here, you can choose specific line colors as well as applying these changes to specific well, sector, layer, and special histories information by going into the Settings option. You can also filter this information. You can also filter this information by searching for it. If I wanted to see my rates in standard conditions under the wells option, I'll be able to do that. As you can see, by default, our gas production is set to red, oil is green, and water is blue. However, you can customize that however you would like. You can also set different options on how you want that information from different files imported in. This is currently set up to use a dashed line with the same color for viewing results from two different data sets. You can also apply all of these same options as well for any sort of profile plots by checking that up there in the top. Another new option to make analysis a little easier for our clients is the ability to view your trajectories and wells through all layers. Previously, a perforation could only be seen in 2D view if you were viewing that specific K-plane that the perforation existed in. Now you have the option to show all perforations from an aerial view or a side profile by clicking on the Wells on All Layers option under the Wells tab. One feature that has been heavily requested is the creation of ad hoc groups in results. Previously, in order to view group information for specific groups of wells, this needed to be predefined in the simulator, or you had to make a custom formula summing up the production from specific wells. Now you can create ad hoc groups on the fly within results. This option is located on the left side, and to add these in, you would click on Insert in the next window. I'll keep the group name as ad hoc group 2, and as an example, I'll add wells 1, 5, and 7 to my new group. You also have the option of applying a weighting factor to each of these wells. Then when you go to your time series plots and go to groups, you should be able to see the new ad hoc group available for plotting. And in this case, I'll be able to see the combined cumulative gas and oil production for wells 1, 5, and 7. There are many options already available inside of results in terms of exporting data, such as exporting images, exporting movies or videos. You can also export your well and reservoir data to an Excel-based format, and also do a bulk export of images into a PowerPoint format as well. Exporting a well summary is an additional option for exporting very specific information in certain columns into an Excel format. One export that is new to the new version of results is exporting a rescue, which is a widely used format for importing and exporting grid structure information, reservoir properties, well trajectories. That means that you can take your reservoir models from results and directly import them into any sort of geomodeling software that you are using. Next, I'll talk about some of the new features that were added specific to unconventional modeling. We have added a lot of functionality in the way we process overlapping and crossing hydraulic fractures in Builder, as well as our simulators, IMEX, Gem, and STARS. This new process ensures much faster load times within Builder, more accurate modeling where different hydraulic fracture definitions share the same grid block space. As you can see here in the image on the right, I am showing a side profile of hydraulic fracture planes that actually have hit and are sharing the same grid blocks between the hydraulic fracture planes. We also have implemented greater control for our users to define their non-fracture zones. Non-fracture zones are the main grid blocks shared by the planar fracture blocks, but aren't the planar fracture blocks themselves. This area, whenever you're hydraulic fracturing, will typically have some sort of increased water saturation or enhanced permeability, or even different types of rel perm curves due to the nature of being near the wellbore while being fracked. By default, the non-fracture zone is extended past the fracture tips up to the full grid block, which you can see on the left image. This new option allows users to specify the non-fracture zone as ending precisely at the fracture tips, allowing more accurate modeling and more flexibility when history matching your models, which you can see on the image on the right, using the option for NFC alignment on. We have also added an option to define fracture height in terms of a distance, such as feet or meters, instead of using the number of grid blocks up or down. This option just makes hydraulic fracture modeling a little bit easier, as you don't need to calculate the number of grid blocks with the grid block width or grid block height in order to get the proper frac heights. For full field models of hydraulically fractured reservoirs, we have added a new feature that allows users the ability to selectively choose specific hydraulic fracture wells to history match by nulling out the rest of the reservoir. This would be very helpful for cases where you're just trying to get better matches in specific parts of the reservoir or specific wells, as the runtime would be dramatically decreased, resulting in much faster history matches. Users can then take their new matches and easily apply them back to the full field model by turning this feature off. We have also introduced the new data import wizard specific to hydraulic fracture injection data, which typically can have data points every second, which is a bit overkill for simulation. This option is available under well and import production injection data. As an example, I'll choose to import frac injection data and import an example file that I have already made. I also have the option of adding in a tracer for each of these stages, which you can see here. When I click next, you can see that my orange line is my original data, which is very simplified just for showing this workflow. But my green line is the average injection rates. In this case, it's going to be specific for a time frame of default 10 minutes. When I click OK, I can see that my new times and rates have been loaded. And I can just check that this injection information from my imported data came in correctly by going into my well events and checking my injector constraints. Next, I'll talk about some added features pertaining to chemical EOR modeling. A new passive tracer option has been added into IMEX and GEM and can be applied to an existing aqueous or hydrocarbon phase, which results in very small fraction of computational costs and minimal storage, which leads to faster runtimes. Multiple passive tracers can also be applied to a single component or a phase. An example of this would be tracking multiple fracture injection stages in a single well and how that specific stage fluid moves through the reservoir. We also have added in a feature to model rate-dependent adsorption. This feature would allow much greater flexibility for history matching, adsorption, and desorption parameters in core floods, or even large-scale models where adsorption or desorption is a primary factor for that specific EOR process. An example of this would be in models such as surfactant injection, specifically where the surfactant is being used for interfacial tension reduction, or even in models where certain polymers give some sort of wettability change. We've also added a new Pitzer Activity Model within GEM. This new model is going to be especially useful for our clients who are using geochemistry in their models, specifically with high salinity brines. This just makes it a little bit more accurate to model these types of reservoirs. And there are two options available, either a simple or a rigorous based calculation for your Pitzer Activity Model. Now, I have talked about a few of the added features within STARS already. I had talked about them in terms of some sort of shared feature. Next, I'll talk about one important feature inside of STARS that was implemented, and that's going to be a new FlexWell formulation. We have implemented a new FlexWell formulation that improves the stability to specific situations in models with vertical sections and maybe wells with trajectories with a lot of undulations in the FlexWell itself as an additional option. Now, this new formulation essentially just improves the stability of how these FlexWells do its calculations, which could result in a lot faster runtimes. Next, I'll go through some additional simulator features that didn't necessarily fall under unconventional chemical or thermal EOR, but a lot of these are going to be shared features. The first one I'll talk about is going to be a discrete fracture network, which is going to be available in IMEX, GEM, and STARS. This discrete fracture network allows our users to specify their natural fractures and fully customize them. Now, these fractures can be oriented in any direction for more accurate and flexible geomodeling, as well as easier history matching. We've also added the ability to control your aquifer influx or outflux using a group control. Obviously, for users that do have aquifers in their model, in cases where you want to maintain a specific field pressure, or you are just finding that you are a bit unsure of exactly what your aquifer influx and outflux is, now you can go ahead and control that using a group control. Obviously, for cases where you're a bit unsure about that aquifer influx and you need to maintain a little bit higher reservoir pressure in order to match your well, oil, water, and gas as well as pressure, you'll be able to easily do that as a whole by controlling your specific aquifer influx. We've also added in a new wellbore correlation within IMEX. Now we do have an existing wellbore correlation already in IMEX, but that is going to be very specific for a single phase gas producer. And what this new wellbore correlation does is it allows you to easily switch on or off if you want to use this correlation for calculating whatever your wellhead pressure is, taking into account any sort of gravitational head and wellbore frictional losses from the perforation all the way up to surface. The biggest difference between this new correlation and the old correlation is that this new correlation will take into account multi-phase producers. So now for wells that have oil, gas, and water, you'll be easily able to use this correlation to calculate what your wellhead pressure is. For users who are using geomechanics within IMEX, we've actually implemented a new simplified geomechanics model specific to IMEX. Now, when you are using geomechanics, stress and strain equations are typically consolidated, or stress and strain equations are typically done separately, but in this new model, they're going to be consolidated into a single equation, which results in mean total stress as the primary variable. Since we're consolidating these equations into a single equation, this is obviously going to give us a lot faster run times. And again, it's just a simplified geomechanics module. But this mean total stress for the grid blocks is then used to modify the porosity and permeability, applying the rock compaction infrastructure that's already available inside of IMEX. One more feature that we did add for geomechanics is going to be Kriging for initial stress distribution. When you are using geomechanics, one thing that you do need is initial stresses defined for each one of your grid blocks. Typically, this sort of information isn't available as some sort of an array for your entire reservoir. Typically, what you will have are points inside of your reservoir where you know what the initial stresses are. So as an example, if I have 3 wells here, or even all of my wells in my model, and I know what the initial stresses are, or even if I know what the initial stresses are at the edges or the corners of my model, I can apply that and define that inside of my data set. And then I can use the simulator to do a calculation, and it's going to use Kriging to calculate what my initial stresses are for the entire reservoir. This makes it much easier, much faster than having to go in and define either a set value for my initial stresses. It's just going to take that information that I have and use Kriging to apply it for the whole model. The last section I'll talk about is going to be simulation speedup. And simulation speedup is going to be all the new features that we've added either to the numerical tuning section or even features that we've added specific to help our clients history match their models faster. MPI support is now available to all of our users. And MPI support is a message passage interface, that's what it stands for. And it allows our users to run field scale models using pretty much an unlimited number of cores. We've done a lot of tests on this new MPI system. Just a few examples of some case studies that we've ran specific to GEM. We've ran anywhere between 2 million to 12 million grid blocks, over 100 wells, and in some really good cases, we've actually had about 63 times speed up using 256 cores. We've also done some similar tests inside of STARS regarding SAGD and steam flood. And again, we've gotten very, very good speed up in terms of how fast that simulation is going to run using 512 cores, 256. We have also ran up to 2,000 cores on some of our very, very large models. with successful results as well. We've also added a new feature called flux boundaries. This is actually available in IMEX and GEM last year, but now we've made sure to include that for stars this year. What flux boundaries allow you to do is to run a full field model, and let's say there's a very specific area inside of your full field model that has all of your wells, or if there was just a very specific well that you wanted to kind of focus on and do your history matching for. Instead of running your full field model, let's say it has, like 2 million grid blocks, what you can do is implement a flux boundary where you take a smaller portion of your reservoir and you specify what the boundary conditions are using that full field model. So as a case study, we actually took a STARS data set. It's a SAGD model with aquathermolysis. So it had 4 reactions in it. It had 4 well pairs and 825,000 grid blocks. On 16 cores, this full field model took a little over 13 hours to run. By using flux boundaries and just kind of focusing along those 4 well pairs, we were actually able to speed up this model. And on the same 16 cores, it was able to run in a little over 4 hours. So a pretty substantial speed up. And the last big feature that I'll touch on just for this webinar is going to be automatic combinative preconditioning specific to IMEX. We have had a feature called combinative on or off previously available inside of IMEX, and there are very specific reasons why you typically want to use combinative on or off. Just as a review, combinative on is very good for high iteration counts. When you're first starting up frontal processes, this is also very good when you have those really high changes in the grid blocks. Combinative on is a setting that tends to work very well and has very good stability when you're running your IMEX models. When you are in primary production mode or even in a frontal process where things are very stable and that front is going to be a little bit further away from your injector, you're typically going to get low iteration counts. So combinative off is a good option for you to use. Now what we've actually done inside of IMEX is hard-coded into the auto-tune keyword. The auto-tune keyword will actually scan how many iterations you're taking per time step, and it'll automatically choose between combinative on or off. It's essentially what's happening. So in some test data sets with IMEX, in these data set or in these models, these can range from anywhere between 72,000 to, 700,000 grid blocks just in these specific tests. Just running auto-tune with IMEX 2019 versus 2020, we were getting anywhere between a 10 to 50% speed up just by using these 2 different versions of IMEX. So very substantial speed up just from going from 2019 to 2020, specific to this new automatic combinative preconditioning. So that concludes the What's New webinar. And again, I had only really touched on some of the bigger features that were implemented in GR 2020. For the full list of features, you can see the What's New documentation included with all of our software. And with that, I'll go ahead and pass it back to Jeremy.
Great, thank you, Jeremy. That was a really concise, well put together presentation of the overall summary. We had some good questions that came in during the presentation. Feel free to send in more questions now as we go through a couple. So the first question I actually have for you, Jeremy, if you could touch base on. So you had mentioned in IMEX that there's this new wellhead calculation option. Somebody was wondering, what's the difference between this versus ISEGWell?
So the new correlation that I had mentioned, that isn't going to be so the difference is going to be with ISEGWell. You're actually using a segmented well to do your calculations. It's not quite like FlexWell, but you can kind of think of it that way. This new correlation is really just going to take the length of your well as well as a roughness, and also it knows what types of fluid are moving in your wellbore. It's just going to be a correlation. It's not it's not doing the wellbore calculations the same way iSegWell would.
That actually brings up another good point. Going back to some of what I had mentioned at the beginning of the presentation, that we actually have this other software package now, CoFlow, for doing the network modeling, that can actually be coupled in as well. And so there's multiple options to model the wellbore side, especially in IMEX and Gem, which can couple to CoFlow and CoFlow X to be able to use these correlations inherent within those, as well as CoFlow, in order to actually model those hydraulics. Another question here, can the fracture creation software be applied in the STAR simulator? This would be for the purpose of simulating the impact of fracturing treatments on SAG-D production. It's a quite interesting question, actually.
Are they talking about hydraulic fracture or like DFN? I mean, I guess the answer is yes to both.
Yeah.
So the question, can the fracture creation software be applied to STARs? There are, well, there are technically 3 different ways to apply fractures now. So we do have hydraulic fractures. We do have natural fractures using our, I don't want to say older way, but our original way of modeling natural fractures you can do in STARs, as well as all of the simulators. And then I did touch upon DFN, which is the discrete fracture network, which allows you to specify your natural fractures and implement them in any direction, in any shape that you'd like, and you can customize these as much as you want. All of that is going to be available in all of our simulators, so it is going to be available inside of STARs.
Yeah, it's actually really interesting. So the grid module that a lot of the hydraulic fracture pieces sit within is shared between the simulators, which is really nice and definitely helps. In terms of the developments, what we found though is over time the workflow side is what needed to catch up. So even though the flexibility was there on the back end, it was just the workflows and even the builder interface and wizards that needs to be implemented for STARs. That's all there. So yeah, you shouldn't have a problem if you wanted to go that route within STARs also. And another question here that I had, so the IMEX stress calculation, the new mean total stress calculation, does it use the geomechanics module?
It's not necessarily going to use the full geomechanics module. It is essentially going to simplify the geomechanics module. So those equations based on those equations getting the stress and strain, it's still taking it into account, but it's going to simplify it.
It's not using the finite elements, I don't believe.
No, it's not. It's all based off of the same thing. It's going to simplify it a lot easier. And then a big part of the speed up as well is it's going to use the built-in compaction dilation within IMEX, not necessarily the geomechanics module, to make those full geomechanics calculations.
So somebody sent a bit of a longer question. I was reading it here. So okay, I think I get this one. So there's a question here regarding the new tracers. And so the tracer components, if I understand this correctly, they're asking kind of how this is being applied. And so the tracers themselves are a new option which basically can track the movement of the different components within the reservoir without adding a substantial amount of the runtime. You're not, in the past, if you wanted to, let's say, inject into 2 different wells and track where the fluids were going, you'd actually have to have 2 different components implemented in order to do that sort of tracking, but that added computational time. With the tracer option, you can track those separately without needing to add a whole bunch of additional time to the calculations. And so there's actually really large benefits and applications to this that's spread between all of the simulators. So it's really going to be a neat thing to see how yourselves can all utilize that going forward. Well, we have a couple more questions that came in, but we're going to be actually answering these offline, if that's okay. Of course, as always, feel free to send in any questions or issues or recommendations that you have to ourselves, either through our our support line at support@cmgl.ca, or through sales at sales@cmgl.ca. All of the information that you're seeing here and more can of course be found through our What's New documentation. As well, this webinar is going to be uploaded both to YouTube and our website shortly afterwards, so you can feel free to rewatch it as many times as you would like. With that said, I hope that you all have a wonderful rest of the day, and see you next time.